quantity, so scalar quantity which have magnitude only. The example are the distance, energy, power, time, speed, volume, density, pressure, work, charge, electric current, temperature, frequency, and masses. Then the vector quantity which have magnitude and direction both. The are the example displacement, velocity, acceleration, force, weight, momentum, electric field, electric magnitude, magnetic field, and angular velocity. Then the system of unit. So the MKS system, meter, kilometer, and second. CGS, centimeter, gram, and second. And FPS, foot, pound, and second. Then the fundamental units. So the length is unit of has the unit meter, mass is kilogram, time second, electric current ampere, temperature Kelvin, amount of substance mole, and luminous intensity candela. Then the supplementary units are the plane angle radial and the solid angle sterling. Measurement of length. So Armstrong, uh, 10 power minus 10, nanometer 10 power minus 9, micrometer 10 power minus 6, millimeter 10 power minus 3, centimeter 10 power minus 2, kilometer 10 power 10 power 3, and light year astronomical distance and 9.46 into 10 power 15. Astronomical unit AU, distance between earth and sun, 1.5 into 10 power 11. And parsec, largest unit of distance, 3.26 light year. And mile, 1.6 kilometer. Fermi, smallest unit, 10 power minus 15. And nautical mile, 1.825 kilometer. Then comes the measurement of mass. So basic property of matter and the dependence on temperature, pressure, and location. So practical units are picogram 10 power minus 15, microgram 10 power minus 9, and milligram 10 power minus 6, quantium 10 quintal 10 100 kg, and ton 1000 kg, and atomic mass unit AMU 1.62 into 10 power minus 27, and pound 0.4537 kg. Then the Chandrasekhar limit, maximum mass of star before the collapse. Then measurement of time, so atomic standard of time and seismic atomic clock. Then measurement of device, so measurement device are altimeter for latitude, ammeter for current, ammometer for wind speed, barometer for atomic pressure, cryometer for low temperature, chrysograph for plant growth by Jesse Bose, dynamo mechanical to electric energy, electroencephalograph ECG, brain electric activity, pedometer, deep depth of sea, galvanometer, pressure of current, and the hygrometer, relative humidity, and lactometer, purity of milk, lux meter, brightness and luminance, and manometer for presence of liquid gas, odometer, distance traveled by vehicle, and pyrometer, high temperature, phyheliometer, temperature of sun, solar radiation, and spigonmanometer, blood pressure, stethoscope, heart sound, and wind value, wind direction. Then come miscellaneous units. So the miscellaneous unit are the gallon, 3.785 lakh liter, and barrel, 42 gallon, and Dobson unit, ozone layer thickness, Cossack, low flow, river, bar, pressure, joule, work, and beta energy, and column charge, ampere, current, and voltage by potential difference, ohm, resistance, watt power, and horsepower, 746 watt, Mach speed of sound, knot speed of ship, and Newton for force, and decibel intensity of sound, hertz frequency, Weber magnetic effects, lux emulance by luminous flux per unit area, and Curie becquerel and radioactivity. Then comes this mechanics. So mechanics, the distance. So the actual length of path, scalar quantity, and unit is meter. So displacement, it is the shorter distance between direction, and vector quantity, and unit is meter and cannot be greater than distance. And speed, so speed Time rate of change of position. So scalar quantity and meter per second, and distance by time. Average speed equal to total distance by total time, and speed can never be negative. Then the velocity, so time to of rate of change of displacement in fixed direction, and vector quantity and meter by second, and displacement by time, and average velocity equal to total displacement by total time. Value change be positive, negative, or zero. Then the relative velocity, so velocity of object with respect to another object same direction, v relative equal to va minus vb, and v opposition equal to relative velocity va by vb. Then the acceleration, so rate of change of velocity is the vector quantity SI unit meter by second square, and acceleration change in velocity by time, and can be positive, negative, or zero. Average acceleration, total change in velocity and time taken. Then the free fall motion, so free fall motion, object falling toward earth under gravitational force, acceleration due to gravity, and value of gravity is 9.8 meter by second square near earth surface, and value of gravity does not depend on mass. Then the circular motion, so velocity is tangible, and direction change everywhere, and always accelerate motion, and terminologies are the time period t, time for the one revolution unit second, frequency number of revolution per time in unit hertz, angular displacement angle swept by radius vector unit radian, angular velocity angular displacement per unit time radian by second, angular acceleration change in angular velocity per unit time, and radian by radian per second square, and centrifugal acceleration towards center AC equal to v power 2 by r. Then comes the simple harmonic motion. So the simple harmonic motion, special type of periodic motion. Particle moves to and fro rapidly, restoring force directly toward the mean position kinetic potential energy. So the mean position potential energy is zero and kinetic energy max, and extreme position kinetic energy is zero and potential energy is maximum. Then the time principle of the pendulum. So t equal to 2 pi under root L by G, and affected by length L and gravity, and increase in summer length increase, and decrease in winter length decrease. So if a girl stand in swing, time period decreases, effective length decreases, and uh, uh, independence of mass, and value of g decreases going up and down, and inside earth pendulum clock. So inside artificial satellite weightlessness g equal to 0, time period become infinite, and on moon g equal to g earth by 6 pendulum clock. So in lift going up the time period decrease, in lift come down the time period increases because gravity is decreases, and if lift string break free fall, the time period becoming infinite. Then the force of laws motions of force, so the action which pulls and pushes a body is the force. So change shape, size, state of rest and motion, and it is vector quantity SI unit is Newton kilogram meter by second square, and force equal to mass into acceleration CGS unit dyne, Newton 1 Newton equal to 10 power 5 dyne. Then fundamental force in nature, so gravitation force, so attraction force between any two object with high mass, it is weakest force, and F equal to g m1 m2 per r square, and g equal to the gravity 6.67 into 10 power minus electron 11 nm meter square by kg square. Then the weak nuclear force, so appearance in certain nuclear process beta decay, and beta decay the beta minus decay neutron to proton plus electron plus antineutron, or beta plus become proton to neutron, so plus positron plus neutron. So beta minus decay neutron to proton, and beta plus decay proton to neutron. Then the electromagnetic force, so forces between two charged particles, electrostatic force, charge at rest, and unlike charge attract, like charge repel, governed by Coulomb's law, charge in motion produce magnetic field. Electric and magnetic field are inseparable. Act over the large distance doesn't depend on intervening medium. 10 power 36 times stronger than gravitation force, and dominated at atomic and molecular level, and undermine the force like tension, friction, and the spring force. Then the strong nuclear force, so the bind neutron and proton in nucleus act between two proton, two neutron, or a neutron and proton only act when particles are very close. Attractive force extremely strong, spin dependent, and stronger force in nature, and 10 power 38 times stronger than gravitation force. Then comes the inertia. So the property to resist change in state of motion and rest due to mass, type of inertia, inertia of rest, inertia of motion, inertia of direction. Then the Newton's law of motion. So first law, so law of inertia, the particle remains in the state of rest of or uniform motion unless an external force is act upon them. Then the second law, so rate of change of momentum is directly proportional to applied force. So F is proportional to dp by dt. F is proportional to m dv by dt. Then the third law of motion, so to every action there is always equal and opposite reaction. And the momentum, what is the momentum? So p equal to mass into velocity, SI unit kg dot m into by second. So law of conservation of momentum. So if no external force, total momentum of system remain constant. And then the work, energy, and power. So work, what is work? So produced when the force cause displacement, and work done by force and displacement in direction of force. Work done equal to F dot ds cos theta. Scalar quantity, SI unit Newton meter or joule. SGS unit dyne, and 1 joule equal to 10 power 7 erg. Work equal to 0 if the theta is 90, and work maximum if theta is 0. Then the energy, so energy is measured as capacity to do work, and scalar unit, SI unit joule, SGS unit erg. Type of energy, so kinetic energy, so measure of work by virtue of motion, and kinetic energy is equal to half mv square. And potential energy, storage energy by virtue of position, so p equal to mgh. Then the energy conservation, so the solar cell, solar energy to electric energy, dynamo mechanical energy to electric energy, electric motor electric to mechanical, microphone sound to electrical, loudspeaker electric to sound, heater electric to thermal, candle chemical to light and thermal, and electric cell chemical to electric, heat engine thermal, no heat engine, okay, heat engine thermal to mechanical, and simple engine have the chemical energy into the mechanical or the electrical energy. The Einstein mass energy equation, E equal to mc square. Then the power, so power, so rate of doing work, p equal to work by time equal to f dot ds by t, that f dot velocity. The SI unit is nm by second, so watt joule per second, and scalar unit, and 1 unit is equal to 3.6 into 10 power 6 joule. Then the gravitation, so gravitation is the gravitation, the non-contact universal force of attraction act between two bodies in universe. Earth attract all bodies toward the center. Gravitation force pull bodies toward Earth. Acceleration produced due to this force is acceleration due to gravity. So G equal to 10.8 nm square near Earth's surface. Then the characteristics of the gravitation force, so doesn't require contact, and equal in magnitude but opposite in direction of two objects. So weakest force in nature, attractive force doesn't depend on the medium, and mutual force. Then universal law of gravitation, Newton, so F equal to m1 m2 by r square, and attractive force directly proportional to product of masses and inversely proportional to square of distance. Then the acceleration due to gravity, so g equal to gme and re square, so change in place to place, and earth inflated at pole and radius less at the equator, so value of g is less at pole and then equator. So value of g is max at earth surface, and value of g decreasing going up and coming down the surface. Then the mass and weight, so mass is a vector quantity, so scalar quantity, so the quantity measuring inertia, and greater mass and greater the inertia. The scalar quantity measured in kilogram, and mass of body cannot be zero. Mass doesn't depend on place and remain constant everywhere. Then the weight, so force which the object attract toward earth, v equal to mg, w equal to mg, and SI unit Newton, vector unit, and weight of object is not constant, change from place to place. At the center of earth, weight becomes zero, and weight at moon, weight of earth by 6, and weight at sun 27 times the weight of earth. Then Kepler law of planetary motion. So first law of motion, law of orbit. Planet revolve in elliptical path around sun. The law of area. The planets sweep equal area in equal time interval. And third law, the law of period. So t square proportional to a square. The square of period of proportional to cube of the area. Then the step velocity, so momentum minimum velocity to project body vertical upward and throw it outer the space, and cross gravitational pull of earth does not return back, and v equal to under root 2 gr, and for earth v equal to 11.2 kilometer per second. Then the weightlessness, so water in invert gas doesn't fall, and weight in the astronaut in spacecraft is zero. Then the heat, so heat form of energy transferred due to temperature difference. SI unit of heat is joule, and flows from higher to lower temperatures. Then the temperature, so quantity expressing degree of hotness or coldness. SI unit is Kelvin. Then comes the measurement of temperature. So thermometer with fixed point and temperature scale is so Celsius. So we have to look this sort of. So the Celsius is the melting point 0 degrees Celsius, boiling point 100 degrees Celsius, and 100 equal part. And Fahrenheit is screen melting point 32 degrees Fahrenheit, boiling point 212 Fahrenheit, and 180 equal part. And the Kelvin is scale melting point 273.15 Kelvin, boiling point 373.15 Kelvin, and 100 equal part. Number scale melting point 0 degree, boiling point 80 degree, and 80 equal part. Rankine scale, the melting point 492 and boiling point 672 and 180 equal part. In the rational between the scale, so C by 5 equal to F minus 32 by 9, K minus 273 by 5, R equal by 5, and RM minus 9492. Then absolute 0. So lowest possible temperature and atomic and molecular motion ceased, and the temperature is minus 273.15 degrees Celsius. Then alcohol temperature, so used to measure temperature below minus 40 degrees Celsius. Freezing point of alcohol is minus 15115. Water maximum density at 4 degrees Celsius. Anomalous expansion of water volume increase with heat density decreases, and water at 0 degrees heated to 4 degrees Celsius decreases and density increases. Mean volume maximum density at minimum volume and maximum density at 4 degrees Celsius, and water heated beyond 4 degree we have like coordinated liquid. Then the change of the state, so the solid to state melting or fusion, and liquid to solid solidification. Temperature remains constant during change of state, and heat supplied is utilized to changing state, and liquid to vapor vaporization, gas liquid condensation. Temperature at which liquid and solid are thermal equilibrium is melting point, and temperature at which liquid and vapor are coexist, this is boiling point. And boiling point point increases with increases pressure, and boiling point decreases with decrease in pressure, cooking difficult to on hills. Then the latent heat, so amount of heat required to change state without changing temperature. And latent heat of fusion, solid to liquid. Latent heat of vaporization, liquid to vapor. Then the transmission of heat, so conduction in solid, heat transfer without particle motion. So the good conductor material, silver, copper, gold, and aluminum. Bad conductor, wood, glass, fiber, and rubber. Then the convention, so fluid in heat transfer by actual motion of matter. So colder, so possible in fluid, so liquid and gases, and heat fluid expand, become less dense and rise, and colder part replace it, and process continue until fuel temperature equal. Land breeze and sea breeze due to convection. Then the radiation, so heat transfer from one body to another body without medium. So without medium, the no medium required, and electromagnetic nature, and heat from sun and radiation, and thermal radiation belong to infrared region of spectrum, and reflected from earth's surface, and heat up atmosphere. Then the black body, so absorb all radiation at any wavelength and emits full radiation spectrum when heated, an ideal black body. And Kirchhoff law, so ratio of emission power of absorption power is same for all bodies at same temperature, and equal to emission power for perfectly black body at that temperature. And good observer are good emitter. Then the neutron law of cooling, so the rate of loss of heat proportional to difference in temperature between body and surrounding. And then comes this wave motion and sound, so the type of waves, so the mechanical waves, so propagation in material medium, solid, liquid, and gas. Example, sound wave. Typical types, Longitudinal waves. So longitudinal wave particle vibration parallel to the wave propagation produced in all metal, and the example sound waves in air at cube wave. Then the transversal wave, the particle vibrates perpendicular to wave propagation, the solid and upper surface of liquid. Then the electromagnetic wave, so don't need elastic medium, then generated by mutual oscillation of electric and magnetic field are perpendicular to each other and called non-mechanical and electromechanical wave, and propagate perpendicular to electric and magnetic field, and speed of light 3 into 10 power 8 meter per second, and uncharged and undetected by electric and magnetic field, and carry energy and momentum. And then comes the term resort to waves. So the amplitude, maximum displacement for mean position, time period, time to complete one oscillation, and frequency, number of oscillation per second, unit is hertz, and wavelength, distance you required to complete one oscillation, and unit meter, an inverse relation between frequency and wavelength. Then sound wave. So sound wave classes by classification by frequency. So infrasonic sound wave, so less than 20 hertz frequency, earthquake, whales, and elephant. Sound wave between 20 to 20,000 hertz human ear can hear, and ultrasonic wave greater than 20,000 hertz human ear cannot hear. Bird, bat, dolphin, and porpoise produce. Then the utility of ultrasonic waves, so medical science. So we have the echocardio. So the medical science, so echocardiography, image of heart, detection of stent and tumor, and break small stone in the kidney into fine grains. Then the industrial uses the clean parts and detect cracks and flaws in metal, and the milk purification destroy bacteria, and sonar, sound navigation and ranging measure depth, distance, direction, and speed underwater. Then the speed of sound, so the depend upon the properties of medium and maximum of in solid and least in gaseous medium. Effect of temperature directly proportional to square root of absolute temperature. Speed at 0 degree celsius equal to 330 2 meter per second. Effect of humidity, increase with increased humidity, and effect of medium speed, increase in same direction and decrease in opposite direction, and effect of pressure, no effect on speed. Then the characteristics of the sound, so intensity and loudness. So the intensity, the rate of flow of energy per unit area, is unit is bell by decibel, logarithm scale. Loudness and softness, so determined by amplitude, unit phone. WHO recommend 54 dB sound good for human ear, and normal conservation at 60 dB, and greater than 75 dB assumed dangerous, and 150 dB can make human being abnormal and mad. Then pitch and frequency. So pitch, degree of sharpness of sound depend on frequency. Higher the frequency, higher the pitch. The children and women had higher pitch, and the voice of lions have lower pitch than mosquito. Then the quality of timber, so distinguishing sound of same intensity, the pinch but produced by different instruments. So it appeared due to presence of different harmonics, and pleasant sound is the rich quality mixture of frequencies, and sound of frequency is called tone, and unpleasant sound is the pleasant sound is rich quality and mix of frequencies. Then the reflection of sound waves, so echo, natural phenomena based on the reflection, reverberation, persistence to sound in large hole due to repeated reflection, and multiple reflection, megaphone, and horn, trumpet, and shanai, and rolling the thunder. Then comes the uh, electromagnetic waves. So थोड़ी देर बाद So the electromagnetic wave. So Maxwell predicted excisions concluded light is electromagnetic wave. Hertz demonstrates the existence. Then the source of electromagnetic wave, so accelerated charge by Maxwell proved, and stationary charge and uniform motion charge do not produce EM, and stationary charge produced when by electrical electric field, and frequency EM uh, wave unequal frequency of oscillation of charge, and Hertz broadcasted radio waves, and Jagdish Chandra Bose produced shorter wavelength EM, and Marconi was first to transmit EM waves over the large distance communication. Nature of electromagnetic wave. Then paired electric and magnetic field oscillation perpendicular to each other and direction of propagation. No material medium required for propagation and can travel through vacuum. Produced by acceleration charge and through AC circuit flow, and travel in infinite space with the speed of light, and uncharged, do not deflected by electromagnetic field and carry energy and momentum. Electromagnetic and spectral, so radio wave, so produced by accelerated motion of charge in conductive wires used in radio, TV and mobile communication. Frequency range 500 to 100 megahertz, and wavelength less than zero point 0.1 meter, and short wave broadcasting up to 54 mhz, and TV wave range 50 mhz to 890 mhz, and cellular mobile phone 840 to 935 mhz, and for FM radio frequency range from 88 megahertz to 108 megahertz. Then the microwaves, so short wavelength than radio wave, suitable for radar system in aircraft, navigation and domestic application. Microwave oven and food item have water content, and frequency of rotation vibration of water molecule point 2.45 to 3 gigahertz. Microwave cause heating of water content by absorption. Porcelain vessel used molecule don't vibrate, and metal containers should not be used. Shock from charges. Then the infrared waves. So infrared waves. So product by hot object wavelength range 1 millimeter to 700 nanometer, and use physical therapy, infrared detector, observing satellite and remote sensing, and semiconductor LED bulb emit infrared used in TV remote control and play a remote role in maintaining Earth's average temperature greenhouse effect. Then the visible light, so the visible spectrum detected by human eye, frequency range 4 by 10 power 14 hertz to 7 by 10 power 14 hertz, and wavelength 700 nanometer to 400 nanometers, and human eye is more sensitive for yellow color 550 nanometer, and snake can detect infrared waves. Then the ultraviolet, so the wavelength range from 400 to 1 nanometer, and the produced by hot bodies. Sun is important source observed by ozone layer, and harmful for skin, and can cause skin cancer. Induced production of melanin cause tanning, and observed in modern glass cannot get tanned through glass window, and welders wear special glasses to protect the eye from UV rays, and used in laser assisted in situ keratomyelitis LASIK eye surgery, and UV emblems used to kill germ in water purifier. Then the X-rays. So The wavelength range of 1 nanometer to 10 power minus 3 nanometer produced by bombarding metal target by high energy electron and diagnostic tool X-ray, radiology and CT scan in treatment of a certain cancer and find crystal structure for certain material and can damage living tissue over exposure avoided. Then gamma X-rays, so gamma rays, so frequency is high and wavelength range 10 power minus 10 to 10 power minus 14 meter, and high penetration power, high energy produced during nuclear reaction and radioactive decay of nucleus and treatment of cancer. Then comes this uh, the static electricity and electrostatics. So the study of effect of interaction between charge at rest and application photocopy machine and computer printer and seismograph. Electric charge, so electric charge rubbing bodies cause charge transfer, and one which lose electron become positive charge, and one which gain electron is negatively charged. Like charges repel and unlike charges attract. New charges neither created nor destroyed. Charge is conserved. Then conductor, insulator and semiconductor. So conductor, so allow electricity to pass easily valence and in conduction band overlap, and electron easily available for conduction. Best conductor silver, copper, gold, aluminum. Conductivity decreases. Then the insulator, so offer high resistance to passage of electricity, large energy gap between conduction and valence band, and free electron not available for conductivity. And example glass, plastic, nylon, wood, rubber, and mica. Then the semiconductor, so the offer intermediate resistance, electrical conductivity between conductor and insulator. Energy gap is not too large, and heat supplied. Electron jump from valence to conductor band, and free electron available in for conductivity. And silicon, germanium, and selenium is the part. Then the this basic properties of charge. So uh, addi- additivity of charges. Total charge is sum of individual charge. Charge is scalar. Charge is conserved transfer of electron. Quantition of charge. Electric charge always integral multiple of electron charge, q equal to ne. An invariance of electric charge. Charge is always associated with mass. Stationary charge produce electric field only, and charge with uniform motion produce invariant electricity, and magnetic field doesn't radiate energy. And accelerated charge produce variable electricity, and magnetic field radiate energy and emit electromagnetic waves. Then the Coulomb's law. So force between two charges depend on the product of charge and distance. So F equal to Q1 Q2 by R square, and F equal to K Q1 Q2 by R square, where K equal to 1 by 4 pi E0 equal to 9 into 10 power 9 nm square and C square. Like charges force of repulsion, and unlike charges force of attraction. Electric field concept first proposed by Faraday, reason around the point charge where other charge experience forces. So electric field AE equal to F by Q vector quantity, and electric field of hollow conductor is zero inside, and charge reside on outer surface of conductor. Then the electric field lines. So electric field lines carry information about the direction of electric field. Strong near charge lines are danger, and positive charge line radiate outward, and negative charge line radiate inward, and start from positive charge and end at negative charge. Two field lines never intersect each other. Then electric flux. So do not dot product of the field intensity and area vector. So then the Gauss law. So the electric flux through any closed surface is the net charge enclosed. So oppose the this and then the difference between static and current electricity. So due to stationary charge exist for short time, use gold leaf electroscope. Current due to flow electron exist long time, use galvanometer. Static develop in conductor and non-conductor doesn't induce the magnification, and current develop only in conductor induce both electric and magnetic field. Then current electricity, so the electric current, so rate of flow of electric current through a conductor is I equal to q by t, and coulombs by second or ampere, direct opposition to direction of the flow of electron, and ammeter used to measure connected in series. Then the type of electronic current, so direct current DC, so magnitude and direction do not change with time, and example cell, battery and DC dynamo. And alternative current AC current, so magnitude and direction change periodically, and AC dynamo. Then the electric potential, so amount of work done to move unit charge from infinite to a point in electric current, electric field. So it is electric potential, the amount of work done to move unit charge from infinity to a point in electric field. Potential difference, difference of potential of the 2 point SI unit, the volt, and potential difference is scalar quantity, and unit joule and coulomb watt, and measured through voltmeter, and high resistance and connected in parallel. Then the Ohm's law, so give relationship between current and potential difference. So electric current flowing through conductor directly proportional to potential difference at the constant temperature. Then I equal to V equal to I, or I V equal to IR. So the resistance ohm. So resistance, so the property of conductor to resist flow of charge, R equal to V by I. Unit equal to volt by ampere or ohm scalar, and the factor affecting the resistance. So length of the conductor wire, L, R equal to L, proportional to L. Cross section of area, R inversely proportional to A. Nature of material, good conductor have low resistance, and effect of temperature, resistance of conductor increases, semiconductor decreases. Then the combination of resistance, so series combination, so the current through each resistance is same, potential difference is difference, so equivalent resistance R plus R2 plus RT. And the parallel combination, so the current is sum of the current in each resistance. So the I equal to I1 plus I2 plus I3, and the total resistance is R1 by 1 by R1 equal to 1 by R1 plus R2 plus R2. So parallel combination has the less than the least resistance. Then the heating effect and electric currents. So current pass through high resistance wire become hot and produce hot, H equal to I square RT. Then the electric bulb, so electric metal with high melting point and high atomic weight, filament made of tungsten, high melting point, brightness of bulb inevitably decrease with time, evaporation of metal, filament become thinner and resistance increases. Then electric fuse, so electric device interpreting current flow in circuit installed in series. So thin piece of wire with high resistance and low melting point, and melt down due to overheating for high current flow, and made alloy of tin and lead. So alternating current AC, so the current varies from magnitude and change direction continuously and periodically. AC changes continuously between O 0 to max value, and flow in one direction in half circle and opposite direction in action half circle, and called sinusoidal wave. And AC power generation and transmission, so the generation station voltage level 11 kV set up to 132 kV for transmission, and voltage set up step down at substation 220 to 240 volt for consumer. 220 volt is effective value, maximum value 311 volt. And in India frequency 50 hertz, and polarity change 100 time per second. So 50 hertz and 220 watt. Then the advantage of SC, so generation is easy and economic, and easy converted into DC with rectifier, energy loss minimum over large distance, and easy change voltage with transference, and it is secure also. So distance of AC, so the shock is attractive nature, and DC shock is repulsive, AC more harmful, and cannot be used in electroplanting, need constant DC supply. AC more dangerous than DC at same voltage real value. Then comes the magnetism. So what is the magnetism? So property of object to attract substance, iron, nickel, and cobalt, and magnetic pole will have maximum magnetic strength. Type of magnetus. So the temporary magnetism, dimagnetism quickly, and soft iron use, and permanent magnet. So magnetize slowly and steadily, that don't demagnetize. Steel and steel is used. Then the use of magnets. So use of magnets are the identification of ferrous material. So manufacturing of hard disk of material, and ATM card containing data information, video tapes and sound recording, and playing accelerated charge particle MRI, and this electric equipment, electric bells, dynamo, and transformer, and maglev vehicle, magnetic leviation. Then the properties of magnets. So Earth behave as magnet. Magnetic field point from south to north, and attractive property of iron, steel, cobalt, nickel, ferromagnetism substance, and directive property, free suspended bar magnet aligned with north to south direction, and magnetic pole always exist in the pairs, and attraction and repulsion of pole unlike the attract and repel, and property of magnetic induction, opposite pole induced in soft iron rod near magnet, and neutral point, no magnetism in center of the magnet. Then magnetic field. So region or the space around the magnet where any other material experience force has both magnitude and direction, from north pole to south pole, and SI unit Tesla, and 1 Tesla equal to 1 Weber by meter square, and CGS unit is Gauss. Then the magnetic field lines. So the imaginary lines representing magnetic field and properties is the originate from pole and end at south pole, and inside magnet, and from S pole to north pole, and close and continuous curl and crowded near pole, and magnetic field is strength high and never interacts each other. The magnetic flux. So the measure of total magnetic field lines passing through area. So unit is Weber. So magnetic permeability. So characteristic of material substance allowing lines to pass through. And magnetic substitutability. So if substance easily magnetized, magnetic substitutability is high. Soft iron has more substitutability than steel. Then the magnetic substance. So the paramagnetic substance. So the poor, poorly magnetized in the direction of magnetic field. Example: aluminum, palladium, sodium, chromium, calcium, magnesium, manganese, oxygen, copper, and tungsten. And tendency to move from the weak to strong magnetic field. Magnetism, the decrease with increase in temperature, and magnetic permeability is more than 1. Then comes the diamagnetic substance. The diamagnetic substance, so not magnetize in direction of magnetic field. Example: gold, silver, zinc, copper, water, alcohol, air, mercury, hydrogen, bismuth, antimony, lead, silicon, nitrogen, NaCl. So move from strong to weaker magnetic field. Magnetism does not change the with temperature. Magnetic permeability is less than 1. So diamagnetic. So the ferromagnetic substance so strongly magnetized in the direction of magnetic field, and the example is iron, cobalt, nickel, and gallium. And with increase in temperature, loss in magnetism, tendency to move away from weaker to stronger magnetic field, and magnetic permeability is more than 1. So it is the ferromagnetic. So paramagnetic and diamagnetic and the ferromagnetic are the magnetized highly. Then the magnetic effect on electric current. So Oersted observation. So the electric current through conductor produce magnetic field around it, called magnetic field effect of effective electric energy. Then direction of magnetic fields. So Maxwell right hand screw rule and right hand thumb rule. Then comes the electromagnet. So the solenoid coil with soft iron core, and attain the magnetism due to flow of current, work on principle of magnetism effect in current, and magnetic effect remain only while current passed. And temporarily magnets, soft iron used for making temporary magnet and utilized in dynamo, electric alarm, and transformer and telephone. Magnetism produced depend on the parameter. So parameter are number of turn in solenoid. More turns, more electromagnetism. Magnitude of electric current, more current, more magnetism. Nature of core substance, ferromagnetism substance make higher field larger. Then comes this force and force on the current carrying magnetic field. So experience a force. So direction illustration by Fleming's left hand rule. Then the electric motor. So rotating device converting electric energy into mechanical energy based on the principle of the force on current carrying conductor in magnetic field. Then the electromagnetic induction. So electric current induced in a closed coil while subjected to changing magnetic field. So Faraday and Henry demonstrated it, and phenomena where current generated by varying a magnetic field, and discovery made intervention of generator and transformator possible. Then the Faraday law of induction. So first law, electromotive force EMF induced the when electromagnetic flux through coil changes. Second law, magnitude of induced EMF equal to rate of change of magnetic flux. Negative signs indicate induced EMF pose cause productive shift. Then the Lenz law. So the give polarity and direction of induced current, direction oppose change in magnetic flux. And electric generator. So based on the principle of electromagnetic induction, device converting mechanical energy into electrical energy, coil placed in magnetic field induced current obtained, an AC generator. So AC generator is coil rotate by mechanical energy, magnetic field change continuously, and current flows through the coil. And after every half rotation, magnetic flux and current direction change, and current is alternative current. And in India, frequency of AC current is 50 hertz. DC generator. So convert mechanical energy in electric energy. So in the this uh, chemical energy to direction of current remains constant. Similar constant for AC generator. Use slip ring and commutator instead of slip ring, and commutator reverse the current direction in external circuit. Then the transformer. So device to change low voltage to high voltage, and vice versa, and based on electromagnetic induction, consisting of rectangle soft iron core made of laminated steel, primary and secondary coil wound on same area, source of AC and connected, and primary and load of secondary doesn't operate for DC, only for AC, and operate only for limited area. Type of transformation, so set step of transformation, so convert low voltage and high voltage more turns in secondary coil, and step down transformation to convert high voltage to low voltage more turn in primary coil. Then the use of transformation, so the in all AC operation for transmission at long distance, domestic and industrial, and voltage regulation for TV, refrigerator, computer, and AC, and in induced furnace. Then the nuclear magnetic response, NMR, magnetic resonance imaging, MRI. So MRI, so NMR, nuclear, so spectroscopy technique based on absorption of electromagnetic radiation by nuclear of atom in external magnitude magnetic field. Nuclei from atom get excited by radio waves in external magnetic field and emit back radio frequency photon, and give details about structure of nuclei, invented by Flexis Bloch and Edward Purcell, and medical use started by Raymond Damadian, and use of study NMR active nuclei, atomic number and mass number is odd, and NMR inactive element atomic nuclear and mass number are even, and nuclear spin quantum number is 0. Then the principle of NMR, so nucleus of atom act as the charged particle due to proton. Nucleus rotate randomly on its axis. Nuclear spin produce magnetic field, act as tiny magnet. Proton present in nucleus rotate randomly. Alpha stage, the external magnetic field impose proton align in the direction of field most stable, and beta spin, so storage radio frequency waves imposed proton get excited and turn 180-degree opposite direction unstable, and the unstable beta spin stage protons and return to alpha spin stage and released radio frequency wave, and NMR spectrum studies to know structure of the material. Then the use of NMR, so magnetic field MRI scan, chemical analysis of chemical industrial field, and structural analysis of nuclear and different material, getting water fat ratio from food and bodies. So MRI, so advanced techniques of radiology use picture internal structure of body, doesn't use X-ray, considered safe, and give better image of soft tissue and organ, and work on principle of NMR, and need NMR active element hydrogen is naturally best, and NMR scan uses H atoms to create NMR effect, and MRI can give a good image of soft tissue. Then comes the this uh, advantage of MRI, so give fractional image, and the create organ, internal organ physiology activity, blood flow can be detected and monitored, and tumors cancer in advanced stage can be monitored, and no use of harmful radiation and SAP. Disadvantages, so very expensive technique, water depreciation organ, teeth and bone cannot be examined, and technique uses strong magnetic field. People with any kind of metallic implant cannot be scanned. Then the human, so it is last now. Okay, so human eye. So human eye structure. So wall composition 3 layers. So external layer the sclera, continuous of corla, and middle layer choroid, choroid extend anteriorly by iris, and inner layer retina help in night vision. Then the retina cells, so rod cell contain robospin, help in night vision. Cone cells help day vision and color vision, and three type of cone: red, green, and blue. Then the lens held by ligament attached to ciliary body, and aperture of eye surrounded by iris is pupil, and diameter of pupil regulated by muscles of iris, and the inverted image from on retina and optical nerve leaves posterior part of eyeball, and rod and cones absent in the blind spot and region, and fovea, the yellowish pigment spot abdominal cone, and the greatest visual activity is fovea. Defect and their correction. So the myopia, so the myopia person cannot see the distinct object and can see nearmost object and image of distinct object from in front of the retina, and corrective by using concave lens, and the hypermetropia, so person cannot see nearmost thing easily but can see distinct object easily, and image of near object from below the retina, and correction use is convex lens. Then the first myopia, so in old age unable to see near and distant object, correction by using bifocal lens, both convex and concave lens. So your physics is completed. So